2. Welcome everyone to our webinar today, Building a Complete RPMA Solution with Leverege. Here beside me is Eric Conn of Leverege.
Thank you, Mike.
Glad you're here.
Glad to be here. Beautiful weather.
It is, always, here in Scottsdale. This is the CEO and co-founder of Leverege, an IoT platform company and solutions provider founded in 2014. All right? So we're going to tell you a little bit why we've got this guy with us here. Eric is a successful serial entrepreneur, product developer, engineer, inventor, and high-tech executive whose past companies include Solipsys, which was acquired by Raytheon, a Fortune 50 company, and Glodo, an advertising technology business. And Eric is also an active angel investor, so any investors or everybody starting something up out there, pay attention, and early stage company advisor, and spearheaded the development of the popular educational publication IoT for All, which is wonderful. I'm a subscriber. That currently serves over 22,000 other subscribers.
Yeah.
It's kind of a big deal.
Yeah, it's good. It's a good time. IoT for All. Just punch it in your Google.
Yeah, it's pretty good stuff. Leverege, his company, is an Internet of Things or IoT software company and systems integrator with a suite of innovative cloud-based products for business applications. And their accelerated IoT development platform and simulation-based approach reduces time to market, lowers deployment costs, and results in better IoT services for customers. Leverege was selected as a finalist, it's a big deal, for the Maryland Incubator of the Year Awards this year and won Best Company Culture for DC Startups in 2016. Check out their website, you'll actually get a good flavor of their company culture, a fun bunch. And the company currently has 2 offices, one in DC and another in Baltimore, Maryland. I am Dr. Michael Vedomske, Principal Data Scientist here at Ingenu. I help bridge the gap between our engineering and marketing team, trying to make things consumable for the masses that can sometimes be technical and very detail oriented. So
Yes.
that's kind of what I do.
That's why you went to school for a long time.
I did go to school for a long time. I have a PhD, but you know it's funny. My kids say I'm not a real doctor because I don't help people get better when they're sick.
You will with some of these IoT devices
Thank
when
you.
we do medical technology.
Thank you. I'll tell that to my children.
That's right.
And I work for Ingenu, which is building the Machine Network, the world's largest IoT network dedicated to LPWA or low power wide area connectivity for machines. We operate on universal spectrum, it's 2.4 band, and the company's RPMA technology is a proven standard for connecting Internet of Things devices around the world. So,
Wow, you must be exhausted already.
I am, but I'm glad to be here. So, we're going to talk today about building a complete IoT solution and how our partnership makes that really fast and simple.
Yeah, great.
Yeah.
Thanks for everybody joining us all over the world. This is pretty cool. So this is my first live stream webinar, so this is a lot of fun.
Yeah.
So IoT is extremely complex. We hear that from our customers. I hear that from my friends and family who don't even know what I do half the time. So how do you break this down? How do you take something so complex and break it down to something that's manageable and understandable? So there's essentially 4 parts to every IoT system. Okay. You have endpoints, which can be called sensors. A lot of, in the parlance of IoT, they're called things. So these are the physical assets. They can be super small or they can be large, that are measuring the physical world and interacting with the physical world. They're on the front lines, you could say, of the IoT system.
Yeah.
They're great to measure things, but if you can't get those measurements off of the device, then they're kind of useless because you'd have to physically go visit every one of them.
Right.
That would be a little silly.
Take a lot of time.
So what you really want to do is you want to connect them to wireless networks, which Ingenu makes a great one, and get that data off of all of these sensors. And we're not talking about just a few sensors. We're talking about tens of thousands concentrated in a relatively small area. So there's a lot of sensors, a lot of data. So you need the right type of connectivity that allows you to get that data off of the sensors to the generic word, the cloud. So that's the third piece. So you have devices, you have connectivity, which is wireless spectrum and RF types of signals. Then you get to the cloud, which is another very abstract term for most people. What is a cloud, or MIST, if you've heard of MIST computing? So it's just a collection of servers in a room somewhere in the middle of nowhere, pretty much.
It's a bunch of computers.
It's a bunch of computers with a lot of blinking lights and a lot of people walking around making sure they stay up all the time.
Yeah, with programs running on them to do
programs running on them to do various types of things.
Yep, that's
and then ultimately the fourth piece of the IoT puzzle is the user interface. Now, user interface can be, everyone has user interfaces. They have apps on their phone. It could be an app. It could be a website.
Smartwatch.
It could be on your smartwatch. And in this day and age, it can be an Amazon Alexa or the Google equivalent where you actually talk to your devices. So that's essentially what makes up an IoT system. And pretty much every IoT system has those 4 discrete pieces, but there's a lot of specialization within each area, and that's what leads to the complexity. Just cloud alone is enough to make people's eyes cross.
Yeah,
Let alone now tie in RF and devices and embedded programming and user interface design and all this stuff, and you have a very complex mess that most people struggle with. But we're here to help save the day.
That's right, superheroes. That's us.
Superheroes, right?
Right here.
You didn't wear your shirt.
I didn't. I know. Well, they can see my muscles.
Okay, that's true.
All right. So now let's kind of hone in on exactly the kinds of solutions and connectivity we're talking about right now. So I guess what kind of solutions, what kind of connectivity are we talking about? Because there are a lot of them, right?
There are, and so there's. When you break down an IoT system and you look at a use case, which is what does a business want to accomplish or an individual want to accomplish with their sensors? What do they want to do? There's essentially 5 aspects that you need to look at when you're looking at an IoT system to try to decide what are the appropriate technologies. There's range, which is, are we talking about trying to communicate a signal like Bluetooth a few feet from each other, or are we talking about in the middle of the ocean to a satellite that's in geosynchronous orbit? Very different types of technologies involved, distances involved, costs and everything. You also have bandwidth, you have power, which are they battery powered, are they plugged into the wall? Battery powered is much preferred because you'd like to be wireless, you want to be able to put these things wherever you want and easily deploy them. Cost is also a driver in this thing. You could have a small number of really expensive sensors, but IoT is really about large numbers, very large numbers of very inexpensive sensors in most cases that are detecting things and as a network can provide lots of trending information. And then finally, scale. Since you want to have a lot of them, you need to have the network connectivity that supports tens of thousands of devices in a very dense environment and two-way communication.
That's right. So we actually have some interesting stats that kind of make it real quick and make it real easy. Yeah, so let's throw that stat up there.
Let's put those slides up there.
Perfect. So one thing that kind of scope it for us here is the simple fact of how much data these devices use that we're talking about, right?
Yeah.
And the vast majority, 86% of them, use less than 3 megabytes of data a month.
Hardly anything.
That's nothing, right? I mean, I've got Word documents that are bigger than that, right?
Yeah, easily.
Not very much data.
I got a single PowerPoint slide that's bigger than that.
Yeah, that's a pretty big slide, right? So not a lot of data. So and it makes sense though if you think about it, right? You know, all you're tracking somebody, right? As they're walking, you're just wanting to know their location, right, and when they were there.
Yeah, and you compress it because you don't need to send it in its fully expanded form. You compress it into a few bits, send it off.
Yeah, and you're good to go.
And it saves the battery life too.
Absolutely, exactly, and that's our next point, right? So the battery life is much longer than, say, traditional things. Now you think about traditional cellular. We all have our cell phones, right? I've got my ancient Nexus here, right? Battery life is, I don't know, a day if you're lucky.
If you're talking on it, maybe half a day.
Half a day, that's right. But these kind of sensors, because they use so much less data and because they're optimized for power, right, for long battery life, you can get 20 years. In fact, this we have a device we'll show you soon actually gets more than 20 years because of the nature of how much data it uses and the way it's been designed and optimized. So long battery life. So that's another that helps us scope exactly what kind of IoT solutions we're talking about. And then finally, you mentioned earlier, range is important.
Range,
right?
super important.
Traditional cellular LTE, right? In a dense urban area, about a square mile roughly. Right. And then RPMA in very, very dense areas. So you can think about places like LA or others. We might get 70 square miles. Here in Phoenix, we get about 200 square miles. We have 10 access points that cover
serving like 5 million people.
5 million people, that's right. And so, coverage is a big deal, and that's important because it makes these things more affordable, the solution, right? Because now you can build a network over a wide area, and it doesn't cost as much as, say,
right, I mean, everyone's seen how many cell towers there are.
There are.
Right, they're everywhere.
That's right.
And with this technology, you need probably 1/100th the number of towers to provide the same level of connectivity, but it's lower bandwidth, but it's more friendly to battery powered devices.
That's right.
Which is really a key selling point of this LP-WAN technology we're talking about.
Absolutely, right. and you just said it. LP-WAN is low power wide area networks.
Right.
And that is exactly the kind of connectivity kind of solutions that we are supporting and that we're looking to talk about today. So let's actually look at a complete IoT solution in more detail and just talk about the different areas.
Let's talk about those 4 pieces: the devices, the connectivity, the cloud, and the UI. Let's start with physical things that we can show to the camera and show the audience what we're talking about. So what's that you got there?
So we just talked about 20-year battery life. This is a fault circuit indicator. And what happens is it goes on a power line like that.
Gotcha.
And when the current goes away, or something happens and current's gone, it actually activates it and it says, here I am, I don't have power, come help me please.
So instead of the trucks driving down the road like they are in, I live out in rural Maryland, there's nothing there but cows and trees and down power lines and thunderstorms. Instead of them driving around or having to have me as a neighbor report that, hey, I lost my power,
right.
The utility company now knows exactly where to send a crew.
Automatically, just like that. So drastically.
And these things can sit out there 10, 20 years, in all weather.
Yeah, we've had a customer that's had these up for years, and obviously they monitor battery level, power level, and how often they send stuff, and they can actually track how long these will last, and these are going to last well over 20 years now.
That's amazing. I mean, you couldn't do that with your cell phone.
No, you couldn't. And obviously, it's a lot less data, right?
Sure.
And it makes sense, but it's been designed for that kind of thing. So this is actually a cool deployment tool that we have. We take it out. You may have seen.
Yep, I drove that around Atlanta with my partner Steve, and we drove 5-6 miles from the tower and worked like a charm.
Yeah, it's beautiful. So that's our this sends out GPS signal or it sends out a GPS coordinate.
Like 99% of that is battery.
Yeah.
Show them how small this stuff is.
So yeah, so here we have. You see these big antenna, but this is actually just a reference board, a development board. So if you want to make an application, you kind of use this as a really quick way to spin up a solution. And if you can see, it's difficult to see, this little piece right here is an antenna, and we have a second one here, okay? And that's actually the size of the antenna, and you don't have to have 2, you can have 1. And so while this is ginormous, this is very, very small, and it works very, very well. And this right here is the module, which is actually what does the processing.
And that's your secret sauce. That's the thing that has all your IP baked into it.
That's right. That's RPMA when it really comes down to it. And here's our newer, smaller form factor. It could easily fit in a smartwatch.
Yep.
Right? And that's what translates, all of this that's being sensed and detected and transforms it into a wireless signal, which then gets sent over the air to our access point. So pretty small, pretty cool.
Very cool.
We have some other cool devices here. We have a smart soul, so this is for loved one tracking, whether it's a child or.
I'm an old soul, but smart soul is probably better.
Very good. And this is a meter module, so smart meters, right? It fits right in there. You notice how round it is right there. This is really where Ingenu got its start. Very cool.
Let's bring out the big ones.
Okay, this is Eric's workout tool.
This is my CrossFit workout.
That's right.
I do AMRAPs on those.
That's right. This is a smart street light, LED. See right here? These are LED lights.
And it is metal.
It is. Yeah, this one happens to be made by one of our partners, LED roadway lighting.
It seconds as a home protection device.
That's right.
Just throw it at somebody.
Kind of Wile E. Coyote style.
Yeah.
That's right. But so our country friends aren't left out. We also have a large lollipop, a soil moisture sensor, right? And what you see, if you can see these green things, these are actually the moisture sensors. And you
Very
can also,
cool.
Yeah, very cool. It goes down 2 feet into the ground.
Yep.
And it can also detect nitrates, so like, do we need to fertilize, that kind of stuff. And it's actually being used right now by U.S. Sugar, who is the largest sugarcane producer in America.
And you were telling me earlier, sugarcane fields are like super dense cornfields.
Yeah, so like grass, right? So you have grass. Now imagine that. Did you ever see the movie Honey, I Shrunk the Kids?
Yeah.
Okay, so remember like when they're in the grass?
Right,
it's kind of like that. Like
yeah.
It's a forest except super dense. And really hard for RF signals to penetrate. They picked us because we got right through it. So pretty cool.
Pretty amazing.
Yeah, it really is pretty amazing stuff.
So from this little postage stamp, that data from all these different types of sensors comes out, and where does it go?
And it goes into the air like this, and goes to
super fast though, not faster than that.
That's right. Speed of light.
Okay.
So it goes to this shoebox-sized device called an access point. And this is really what happens. So there's an antenna that attaches to the bottom, right, and it goes up, and that's what gets the signal.
So another name would this be like a gateway or a
Gateway.
router, like things you
Yeah.
might have in your house. You know, if you have
Exactly.
Comcast or Fios, you got a little router. This is an industrial version that works with their network.
Exactly,
Same
yeah.
sort of concept.
Waterproof, right? So it can
Yeah.
be outdoors, all that kind of stuff,
Right.
right? But yeah, really, it's basically like a Wi-Fi router, if you think of it
Right.
that way, or a gateway,
Right.
or all those things. Yeah, exactly. Right. So the antenna attaches here, and it also has Ethernet, right? So that once it gathers the signal, processes
So
it.
it's taken tens, maybe hundreds of thousands of
Yep.
devices are sending little discrete signals, measuring temperature, measuring soil, humidity, all that comes across into this one guy.
Right, and this can simultaneously demodulate at least 1,000 signals at a time. And
Wow.
that sounds pretty, demodulate is a cool word. Basically,
I like that one.
it can read those signals at the
Right,
same time
right.
and then send them on, right? And that goes through what's called backhaul, which is the internet, basically, right? So either over a cellular signal, right? So you have two redundant ones, or over Ethernet, whatever makes sense for that.
So if you can envision out there, you have a relatively small pipe of data coming from each one of the sensors.
Yep.
Sort of think of a thinner pipe.
Mm-hmm.
This takes all the collection of small filament-sized pipes.
Yep.
And then the backhaul is a much thicker pipe that you could fit everything in. All the data can go through one.
That's
pipe.
right.
And that could be either IP or cellular, high bandwidth cellular.
That's
And
right.
then these guys are powered, right? These
Yep.
are not running on batteries.
Yeah,
These
powered.
are in a building somewhere.
Well, so these get, yes, you're right. They are power over Ethernet.
Yep.
It's actually
And
it's not very.
so for the whole city of Phoenix, 5 million people,
Mhm.
10 of these puppies can basically
Yeah.
cover that whole
Cover
city.
5 million, that's right.
That's amazing.
Absolutely. Yeah, it really is, it is pretty amazing. And what's neat is this over a month's time is probably on a plan similar to or less than what you use for your cell phone. Right.
Total data,
Total
aggregated
data
and sent through
Over
this.
an entire area, say 200
Yeah.
square miles and tens of thousands, hundreds of thousands of devices, less data. And
Wow.
that really kind of shows you the kind of data these sensors use. Anyway, okay, so it goes here, and then it gets sent, like we said, over the internet to the cloud. And then
Right.
let's go ahead and pull up our Intellect platform, and that is our cloud-based platform that offers a REST API for various users to access the data.
Okay, so this is where all the data that comes off of that shoebox you just showed comes into this portal. And so this is running on Ingenu's cloud, not to be confused with Leverege's cloud, because
Right.
we have multiple clouds.
Right.
And each one of these panels here represent a device and a particular type of protocol. You can see AMQP, a very standard protocol. Here's a REST API, types of things. So as all the data comes into Intellect, it ultimately will connect from here, and this is some of the magic we've been doing behind the scenes as a team.
That's right.
Is we've been connecting our cloud, which does all the analytics and all the fancy AI types of things to your data to add insights into it, to this raw data that's coming across into Intellect.
That's right.
Right. And so essentially, once it gets here, sort of the magic of our partnership is we've already spent several months building everything we need to take the data, which comes here in a very raw, packed format. In a lot of cases, each device might have its own type of format. They call it a payload, which is the actual
That's the
data that
message.
you carry. That's the actual message, but there's also a header on the front of it that tells time and sequence numbers and other types of bookkeeping types of information. So we've sort of negotiated that between our two companies. So we have these standard interfaces already built up, libraries of sensors already supported, already integrated end to end from the device all the way to our cloud, which ultimately gets us to user interfaces. So the two pieces that Leverege focuses on are the cloud analytics and the big data type systems where you're analyzing the data, but also the user interface. So ultimately, all this data is really nice to talk about, but if you can't see it, then it's kind of hard for a human to do anything.
Yeah, you need to be able to use it.
You need to be able to use it. So what I'm going to show you here is I'm going to run through three notional interfaces that we built. I mean, these could be real, but for the purposes of the webinar, these are notional interfaces. They could be tied into real sensors within a week, and you could actually have things happening. This one is a sort of one of the smart city applications we both have seen a lot of traction on. Is around trash collection or optimization of city services. I'll just call it that.
Sure.
So in this case, here's the city of Phoenix. We have a little heat map, and certain parts of this are actually functional. And as mentioned, one of the elements of our UI and our platform in general is the ability to simulate data. So these are not connected to real trash trucks and bins, but there's a few hotspots here in Phoenix. Let's pretend there was a concert and you have sensors deployed on the RPMA network that are detecting trash levels, or whether the trash smells good or not. You
It's
can have
air quality.
air quality type sensors. So you can imagine a city worker sitting somewhere in a building that says, "Oh, I need to deploy some of my trash trucks to go pick it up." So I'm going to go over here to maybe I'll do Central City. I can click deploy, so we got an alert. And what you'll see here, let me get it set. So this little blue dot that's moving around is a trash truck, and is now going around. And you can see the yellow dots. Hopefully you can see that as on the screen there. It's driving around and it's picking up all the full bins, and you can see the bins start counting down as it removes them. It just went off screen for a second there. So this we actually simulated in our cloud-based system, which is one of the powerful things about our platform versus some of our competitors, is the ability to script and simulate in very high fidelity the entire use case while the hardware is being built and deployed.
And that's important because now you're doing things in parallel. When you take things in sequence, you're kind of waiting on the
Exactly.
step before. But this way, you can hone your solution down, hone it down to exactly what you want it to be, and make sure that you are meeting the exact needs that the company has or your end users have without going too far or doing too much or too little. So you can really
And
solve the problem.
you could set up things like contacts and have people get texted. It's a fully interactive system. So this is one notional use case. You can imagine this sort of interface could be applied to any number of cases where you have sort of collection, routing, optimization, efficiency. It doesn't have to be trash.
Where's my Pizza Hut, right? Where's my Domino's? I want my, where is it? So the dispatcher, anytime you dispatch anything, this could easily be that.
Yeah, and the sensors have gotten so inexpensive these days that you can track almost anything relatively expensive. You can put it up on your network. You don't have a cell bill. See, that's what's really important for people to understand is the cost to deploy it on a network like RPMA versus if you think about your cell plan, where every time you put a phone on your personal Verizon network or AT&T network, it's $40 to $50 a month.
Oh yeah.
We're talking about less than $1.
Oh
right?
yeah.
Right.
Yeah.
Pennies probably, because there's little small amounts of data. Just run through a couple other common use cases we see. So this is like a smart city use case. You could layer in all kinds of other stuff on top of this. So let's look at tank level monitoring. Let's say you're a small business, and there's millions of them in the country that are service station. They have fuel tanks, they have regular and premium. I don't know if you guys knew this, but sort of the mid-grade is actually, they mix. They do not have a separate tank just for mid-grade.
I heard that.
Yes, they just have regular and premium, and then they mix them.
Yeah.
So anyway, so in this case we have a notional service station. Let me go to a different one here. You can see the tank levels change, and we get this super fly in.
No, that's nice.
So here we are down on Broward Boulevard down in Fort Lauderdale, and you can see the station owner can check on his regular and fuel tanks. You can see his diesel fuel tank. You may have compressed air. And most service stations in the U.S. now have to accept customer waste oil. So this one actually fills up, and you need to get it removed. So you need to know about this. So believe it or not, even in this day and age, most service stations, gas stations, do not have an automated way to know what the level of these tanks are. You've probably seen these big fuel trucks pull up and then get out with these very long sticks, so they stick them down into the bottom of the tank to measure how much fuel is there. And that seems archaic, but that's the way they do it. They could take a few ultrasonic sensors specifically made to measure these types of fluids and deploy them for probably $5,000, and they can have it done forever and have it up on the network. That's a hard cost, and then for fractions of $1 a month, be able to know in real time what all the levels are. I mean, it's something that simple saves a tremendous amount of time.
And that's just the beginning, right? So once you can start to measure these things, then you can start to optimize.
Exactly.
And then you can do routing better. You can basically kind of do what a lot of the delivery companies like UPS, FedEx, and others have done for years, but have paid a big cost to do that.
Right.
Now is more affordably done by sort of the rest of us, right?
Yep.
Smaller companies, businesses maybe that aren't conglomerates and ginormous, and are able to do pretty sophisticated things now that you actually have data to analyze and collect, especially when you have a partner like Leverege and others, right, and ourselves, to put it all together and make it real simple to deploy.
I mean, not a day goes by, even in the popular press now, where you hear about artificial intelligence, machine learning. It's a real trend. It's really going to affect everyone's lives very quickly. It already is. And so the first step is get the data, and then, like you said, start analyzing and optimizing it. And that's where a lot of these really advanced machine learning type techniques can really give you great insights into your business and help you optimize things. I'm just going to show one final use case. This is asset tracking for say heavy construction type of vehicles. So if you have a lot here, this is in Baltimore, you might have a lot where you're doing some construction here in Little Italy, which has pretty good Italian food.
It does.
Have you been there?
Oh, I have.
Yeah. So maybe you want to draw a very odd shape. Whatever.
Sure. Yeah.
Label it. So this is your construction site, and you may have equipment in there, and you want to do preventive maintenance. So heavy equipment like this would cost hundreds of thousands of dollars. You want to make sure you stay up on the investment that you put into it, and make sure all the preventive maintenance and all the wear and tear. So you could have sensors equipped all over the vehicle, tied to the engine system, the various actuators, hydraulic systems, and have it report back to a central place. Parts wearing down, fluids running low, all those types of things, so that you can keep, in this particular use case, you can keep your stuff running at top performance and never have downtime. I think we were talking earlier, some of these large mines that have those gigantic trucks that probably hold 10,000 cubic feet of dirt.
Yeah, they're bigger than this building.
They're
at least
huge. There's really one road down. As they start building the mine, they sort of wind down around the edges. When one of those trucks breaks down, no one can get past it. That can cost them $1 million a day of being down because they can't extract ore, gold, silver, whatever they're taking out of mine.
Yeah.
So you really want to stay on top of the preventive maintenance. And so if you can tie in sensors and measure types of wear points, and then do all your preventive maintenance ahead of time, it saves a business millions of dollars for a really low cost.
Yeah, and the beauty of RPMA and LPWA generally is that now you can do it for things that aren't $1 million a day lost, right? You can do it for things where the savings is smaller but still meaningful to your company. So whatever company has to do this sort of maintenance and that kind of thing, it still makes sense economically and it's cost effective.
Yeah, so I think...
Well, there's one more. So on your tank level monitoring, I was looking at it and it made me think about, you mentioned gas stations, but there are so many different things you don't really think about, like oxygen tanks. How many medical oxygen tanks are there out there, right?
No, millions.
And you can sell a subscription service to these oxygen, whatever medical company you are, you sell a subscription service and say, look, we'll automatically monitor it, or we'll get reports, and when you're 80%, we'll bring you a refill. Right, automatically, and that's good for some patients who maybe can't take care of themselves.
And who wants to go find the tank, bend down, look at the valve? I mean,
that's right.
And there could be malfunctions too.
Absolutely.
Maybe there's leaks. There's things like that where you wouldn't expect it to go down, and now all of a sudden it's leaking, and now you're out of oxygen, and it's a real medical emergency.
And a liability.
So, yes. So from a safety standpoint, there's so many ways to just be able to measure the physical world, whether it's just natural phenomena or man-made type of things.
Absolutely.
IoT, that's why IoT is such a burgeoning field. There's so many things you can do with this. And fortunately for us, our partnership enables you to do that really quickly and inexpensively, because we've done a lot of the heavy lifting behind the scenes to enable it.
Absolutely. One of the things that we've kind of implied and haven't said maybe explicitly, that I will state explicitly, is just vendor management, right? Think about the 4 different parts of a complete IoT solution we talked about, right? So RPMA is, we have an RPMA ecosystem, and Ingenu has a stewardship and has worked on partnerships and others who make devices, but who also, we have multiple module vendors, right? So that our different solution partners can integrate those into their devices. And so we've helped to develop that and are continuing to develop that. So there's a large number of different solutions or devices that you can use for your solution. And we maintain this, right? We make sure the network is professionally run. Everything is taken care of, so you don't have
You're
to.
providing a service level agreement to your customers that says
Right.
the network will be reliable,
That's right.
available, whatever type
Right.
of weather, whatever time of day, you're going to provide the service just like everyone's accustomed to.
The
with
same,
their-
that's right. The same
Right.
way you think my network needs to be there,
Yes.
same thing applies to the machine network.
Because the more embedded IoT solution gets into your business processes, the more important it is. Because
Absolutely.
it is a mission critical system at some point, because it's saving you countless dollars to the bottom line on a daily basis
Yeah,
once it's fully implemented.
And just a cool stat, and I like this stat because it just shows you what it takes to really build a professional and high performance network. We've got over 600 person years, in developing RPMA and actually running the network. That is a lot, and so that's one of the beauties of having a public area network is that you've got all of that expertise.
Not to mention all the IP, you guys have invented a lot of cool stuff.
39 patents. I mean, that's kind of a deal. Anyway, so there's that, right? So you have a professionally managed network, a growing and powerful ecosystem of partners, and then there's all the stuff that goes into designing a very user-friendly and usable interface, as well as managing all the cloud side stuff, databases and things that you've already solved.
Right, yeah, each one of these, the device layer, the connectivity layer, cloud, and UI, each one of them is its own area of discipline and sub areas within each one. There's so much specialization that goes on now. It's what makes it very hard for customers is tackling that complexity of where do you start when you want to build an IoT system. You want to automate some process in your business or even in your private life. How do you wire it all together? There's so many pieces involved. And what we've done is we've really severely reduced the friction and the time to market for anyone who wants to do something that makes sense for an LPWAN type of connectivity, which is a large segment of the IoT use cases. LPWAN makes a lot of sense for them.
Absolutely. And also thinking about just one of the things that our partnership brings is it's expandable and it's open. So let's suppose you need to add a device or you want to add something else to your solution, whether it be maybe you need to swap out the database. Perhaps there's a new database needs to be developed. You're able to do that.
Right, because we have the expertise. We understand all the different nuances of the different types of SQL, NoSQL, BigQuery, just all these different databases. That's our job. That's what we're trained to do. So we do best of breed. So you really, with our combination of our teaming is really it's kind of future proofs, which is really important because the technology is moving so lightning fast for everybody that you have to be able to plug and play new things. For instance, we talk about putting voice interfaces. Well, a year and a half ago, people would not have really thought of having an Alexa be the primary way that you interact with your IoT system. But we have several customers now that are using that as that's a very natural way. They don't want to have to pull up their phone. They don't want to have to go to a website. They just want to ask in their home, how is my boat doing? For instance, we have a connected boat customer. So
absolutely.
So there's a lot of new technology that can be applied to IoT to just make it even better.
Yeah, and RPMA uniquely as a wireless technology is two-way, right? Completely two-way, and it supports firmware upgrades. So let's suppose you want to change some functionality in your device, maybe you want to do a security update. We support that in the background, right? Background firmware updates, which is huge. That's
really big because if you can't support over-the-air firmware, then you'll ultimately strand your device because either maybe you just want to update the rules. On the local device as it detects and how it reports. Well, if you can't do that, then you have to physically go visit every device and plug in a USB cable or something. That's impractical, especially when they're buried in concrete for a smart parking application.
Exactly. And one other thing that kind of future-proofs the solutions that come out of this partnership is just some of our earliest customers. An example of this: some of our earlier customers, they installed the smart street lights we had earlier. These babies, right? So they started with this. And they liked it so much, and they said, "Well, man, let's add something else." And so they have smart metering, or they would monitor their transformers and other things. And so you can expand.
Yeah, just layering new things on top.
Layered in, that's right. But if it's a private network, now all of a sudden you have to try and manage new infrastructure, to put up more infrastructure, and it's much more complicated than just simply adding devices. So it's a very different beast.
Great.
Anyway, I think we're about out of time, Eric. We've said quite a bit.
Okay.
However, we've been getting questions throughout our presentation here.
Okay.
So we'll go through some of those questions, and I guess we'll just address them as appropriate.
So you want to, how about the one from Satish Menon, number 4 there?
Okay. All right, sounds good.
That was I figured you
Oh,
got
yeah,
this
that's
one on the
great.
tip of your
Okay,
tongue, right?
Satish, thank you for sending that in. All right, so what is the range of your access gateway in miles or kilometers? Okay, so I will answer it, but first I'm going to start with this. Range is definitely a number we'll talk about, but I'm going to rephrase your question in terms of coverage, and here's why. Because it's really simple to get range cherry-picked, or you can easily find circumstances in which you can get a really long
Right, because
range.
that line of sight is always going to perform the best. So
Exactly.
if you can put the access point up 2,000 feet in the sky,
2,000
and have
miles in the
it-
sky.
yeah, and have it shine towards something, you can get hundreds of miles with
Right.
this, right? But that's not practical.
Yeah, it's not practical, and it doesn't really reflect our experience as we are using devices in the real world. So that's why we like to talk about coverage area, because it's coverage over an entire area, and you want to think about it in terms of how reliable is that coverage for all the devices in an area, because that's going to help you really understand what performance you should expect. And so I'll give you some numbers on range. Our current record, as given to us by one of our customers, is 88 miles, which is ridiculous and obviously not typical.
Right.
And we actually found out what was happening is some of the signal was bouncing off of the atmosphere, because 88 miles is actually longer than the curvature of the Earth between 2 points at that height.
Yeah.
And so it shouldn't be able to actually go through Earth, but because it bounced off the clouds. But that's
I
ridiculous.
worked on just the side.
Sure,
I worked
sure.
on a Navy system called Over the Horizon.
Uh-huh.
That's exactly what they did. They would bounce it off the ionosphere
Well, there you
to
go.
get the signal, and they could get thousands of miles. So
Yeah, but
physics works like that.
it does, yeah. But that's not realistic, right? So in to expect all the time. We have other solutions right now. We announced just a few days ago, actually, with Aurelia, they have a vessel tracker, and they use our connectivity to track vessels that are 30 to 40 kilometers out over the water. And we have a solution down in Choquinta, which is a bunch of meters. And what happened? There was a construction accident, and one of the access points went down, and so all the meters that were connected to that access point actually reconnected automatically. That's just how our system works. And when they reconnected, a few of them connected to an access point that was 50 kilometers away, so 30 miles about.
Yeah.
And that was just real world.
Well, I can tell you, completely independent. My partner and I drove around
Mm-hmm.
Atlanta, which is a very challenging city. If you've been there, it's very hilly.
Mm-hmm.
And we drove around with one of these guys, and you had one tower that was probably 5 or 6 miles away, and we had coverage the entire time we were driving
Yeah.
in the car. So, we've been really impressed. And we're not hardware guys. We're software guys, and we've been very impressed with the coverage.
Well, good to hear. Good to hear. But so to be the short answer is, we get 300 square miles of coverage per access point in a nice rural area, and in urban it can be 200 square miles. In really dense urban, 70 square miles, and that's totally typical. I mean, look at our coverage maps. Like I said earlier, Phoenix is 2,000 square miles, and we have about 10 access points that are covering the area. So there you go. I mean, and this is live network. So there's that one. All right, let's see. What else do we have here?
Well, Mark Bowen, actually, Mark, nice to meet you out there. Mark works with he's another customer of ours.
Oh, okay,
He's sent
great.
in a bunch of questions. You want to pick
Sure.
one of those?
Okay, so let's see. Who owns and maintains the gateways? Customer, or does someone sell it as a service? I'm glad you asked that question. So that's on me, because I guess I should have done a better job explaining. Ingenu is building what's called the machine network, and it is a public network, wireless network, just like a cellular network, except it's owned by Ingenu rather than, say, Verizon, right? So it's a public network in that we sell subscription. Just like you buy a subscription for your
Right.
phone,
Mhm.
you buy a subscription for your devices. Obviously, the cost is much lower for devices, but it's the same way. Operates the same way as a cellular network. It's a star topology, so there's a tower, right, which then broadcasts signal, and that's what you use. So just like a cellular network, Ingenu owns the machine network. It's building the machine network in the U.S. We have licensees that are building it internationally, and they will have a similar relationship to their customers as we do. And you sell it just like Verizon sells subscription service to Eric.
Sure. So I'll take Sudhir's question on what's the advantage of Leverege over IBM Watson or Microsoft Azure. It's really not an advantage, because we actually use Leverege. That's why I named the company that way, by the way. so I'd accidentally use it in sentences. So we actually embed and access via API IBM Watson. So they have some really cool analytics. There's no reason for us to try to rewrite all those analytics. So we just use them as a service through their API. In terms of Azure, we're sort of cloud agnostic. So we're a very open platform. We really focus all of our effort on the application level of IoT, which all the big tech companies, Google, Microsoft, AWS, they focus on sort of the commodity, but it's still a really important piece of all the cloud architecture. So we use them when appropriate to build our reference architecture, so they're underlying it. And IBM Watson, we have some specific things that we can do with analytics, but there's some things that Watson can do that we can't do. So we just use them in. So it's not really, we're not competitors. We're actually bundled together.
Yeah.
Depending on, it really depends. A lot depends on the use case and the type of data you have. Analytics only makes sense when you have the right types of data.
Very good.
We have any time for any other ones?
Yeah, let's see. I think so. Let's see. And sorry, questions here. That's already answered. That looks like that was already answered.
Did we answer the one about LoRaWAN?
Where is that one?
Number 11.
Here we go.
Andrews.
Okay. Is RPMA pitched at a bit more data than LoRaWAN? In other words, not competing but different. Okay, good question. So, LoRaWAN as a technology does support very low data throughput, very low data throughput. And so the question is really, how are we competing as far as what kinds of applications we serve? And I'll just say we serve all the applications that they serve, and then others. And we have the security built in. We have 100% message acknowledgement. We have, forward error correction. We have extremely robust signals. I guess the only thing, one of the main differences is LoRaWAN typically is being used for private, small, local area networks, which is probably more appropriate for LoRa.
Yeah. So I mean, we're independent of this discussion in some ways because we're a software.
Yeah.
But just to explain, because it is confusing. LoRa, RPMA, Sigfox. There's all these different, all under the umbrella of low power wide area.
Yeah.
So the LoRa community, which is an open standard, but it's managed by Semtech. They have their equivalent chip. Mm-hmm. That speaks LoRa. It's the physical layer. Yep. And then LoRaWAN is the MAC layer that sits on top of it that does the networking layer. So they're different, but they try to solve the same problem.
They do.
Right.
Yeah.
Right.
So we are in the same class, low power, wide area networks. While we do absolutely support more data-rich experiences, we support very low and very cost-effectively low data experiences as well. So we really overlap in terms of all the kinds of devices we support and compete for. So
sure.
Yeah, that's a good question. And we have some great white papers that can go in more detail about LoRa as well as RPMA to help answer any more specific questions. So I suggest going to our website, ingenu.com, and looking at the downloads there and downloading whatever ones. And
we also have a bunch of white papers on leverege.com, spelled with all E's, on the differences between LoRa, RPMA. We're completely unbiased. We're just looking at them sort of as a technology set.
There you go.
And so feel free to go there. There's 3 or 4 white papers that we have up there that will sort of walk through all the different types of LPWAN technologies that we've interacted with.
Good. I think.
How are we doing?
So we got one. Let's see. Is there something we can answer quickly? I don't know if we can. Is there? Oh, okay. So Mark Bowen, question: are there any custom protocols to implement on the sensor to talk with the RPMA module, or is it IPv6? It's not IPv6, and there are a lot of really good reasons why it's not. So we do have a custom protocol to talk with the module. It's pretty straightforward. All the people that we've talked with that are serious about making applications pick it up really quickly, and it keeps it secure, right? So we're out of anything that can basically attack IP-based systems.
Right, but important for IoT security is the #1 concern of every customer is IoT security.
So we've just removed an entire source of or vectors of attack. As well as it just is more efficient to not use IP. I mean, and you'll see that.
Well, the headers alone would eat you alive, right? So when you're talking about sending 20 bytes at a time and you have a header that's 64 bytes, that
Yeah.
doesn't work out too well.
Yeah, but anybody who's trying to put an IoT solution together or a device and wants to integrate our module, you'll find that you've got the chops for it. It's really not crazy. It's pretty straightforward. So all our customers have been pleased with it. I think that's all time we have for today. Eric, thank you so much.
Thank you, Mike.
Yeah, it's been a
It was
pleasure. We'll have to do this again. So thank you
Yeah.
all for coming. And
Yep.
like we said, check out our websites and get in contact with us. We'd love to help you make your complete RPMA-based solution using Leverege.
Yeah. Thanks.